Combinatorics, or simply the study of counting things, is a too often forgotten branch of mathematics that is extremely important for computer science and statistics. This video will go over basic counting techniques and will introduce the fundamentals of combinatorics, permutations, and combinations. The only thing you need to know for this lesson is how to multiply and divide numbers. Whether you are watching to learn for a math class, preparing for math competitions, or just using it as enrichment, this video will give you a good baseline to learn more from. I'll start with a simple problem. A man has 2 hats, 3 shirts, and 2 pairs of pants. How many different outfits can he make using 1 hat, 1 shirt, and 1 pair of pants? We'll tackle this problem with a tree of possibilities. He can wear one of 2 hats, which we'll call hat 1 and hat 2. With each of those hats, he has a choice between 3 different shirts, which we'll call shirt 1, shirt 2, and shirt 3. Now with each of those shirt-hat pairs, he has a choice between 2 different pairs of pants. Each time I write P1 or P2, it represents one of the possible outfits that I can create. Counting up all of the outfits, we see there are a total of 12. This is nice, but the important part comes when looking at what happens at each part of our tree. The first layer has 2 possibilities. And going from the first layer to the second layer, we multiply 2 by 3 to get to 6 possibilities. And at the third layer, we take 2 times 3 times 2 to get to the total 12 possibilities. And this is our trick. We can multiply independent possibilities together to get total possibilities. And now for our next question. A man has 4 hats, 5 shirts, and 4 pairs of pants. How many outfits can he make? This problem's a little hard to do with a tree, but we can use our trick instead. We can just take 4 times 5 times 4 equals 80 total possibilities. Our next question is a little bit more confusing. You have an urn filled with 3 slips of paper, one with a 1, one with a 2, and one with a 3. You pick one out, write the number down, and replace the slip of paper. Repeat this process until you have a 4-digit number. How many different 4-digit numbers can you make? We're going to use the same trick for this problem. Pause the video if you want to figure it out. For the first digit, we have a 1, a 2, or a 3. For the second digit, we have the same 1, 2, and 3 as possibilities because we replaced the slip from the first digit. For the third and fourth digits, we have the same possibilities. Thus, our answer is 3 times 3 times 3 times 3 equals 81. Next, we're going to tackle permutations with 2 simple problems. How many ways are there to order the letters in the word stamp? We could just list out every possibility, but there is a much better way. We can think of it sort of like the last 2 problems. Pause the video if you want to figure it out. For the first letter, we have 5 possibilities. We can choose any letter we want. For the second letter, we have 4 possibilities, every letter except the one we chose for the first letter. Similarly, for the third letter, we have 3 possibilities, for the fourth letter, we have 2, and for the fifth letter, we have 1. We can multiply these possibilities together to get the total number of possibilities, which is 120. This is also a good place to introduce factorials, or a whole number times all of the positive whole numbers less than it. So the answer is also 5 factorial, which we write as 5 exclamation point. An important fact is that 0 factorial equals 1. This answer is also called the number of permutations of the word stamp. And now for our next question. You have an urn filled with 8 slips of paper with numbers 1 through 8 on them. You draw 4 one by one and write down the numbers in the order you get them. How many 4-digit numbers can you create? We have 8 choices of numbers for the first slot, 7 for the next because we did not replace the slip, 6 for the next, and 5 for the last. So our answer is 8 times 7 times 6 times 5, which equals 1680. This number is also written as 8p4, which equals 8 times 7 times 6 times 5. The formula for NPR is n factorial over n minus r factorial. This looks a little confusing, but if we look at the case of 8p4, we see it is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and the 4, 3, 2, and 1 all cancel, so we're left with 8 times 7 times 6 times 5. Our final topic is combinations, and we'll just do one problem with combinations. You again have an urn filled with the same 8 slips of paper numbered 1 through 8. You pull out 4 of the slips. How many different groups of numbers can you have? You might be tempted to say it is also just 8p4, but that is incorrect, and I'll explain why. 8p4 accounts for the order we took the slips out, but for this problem, the order doesn't matter. For example, you could have picked 1, 2, 3, 4, or 4, 3, 2, 1 and gotten the same group. So with 8p4, we have counted each possible group of numbers multiple times. But now the question is, how many times have we counted each of them? Looking at the case of 4, 3, 2, 1, we can see that we counted it 4 factorial ways, because that is the number of ways we could have ordered 1, 2, 3, and 4. This is the same for every group. So we must divide 8p4 by 4 factorial, because for each possible group, we've counted its 4 factorial different orderings, and to fix that, we must divide by 4 factorial. Thus our answer is 8p4 over 4 factorial over 8 factorial over 4 factorial times 4 factorial, which ends up as 70. There are two ways of writing our answer: an 8 on top of a 4 inside of parentheses, or 8c4. The formula for this function, known as the choose function, for variables n and r is n factorial over n minus r factorial times r factorial. Now in conclusion, we multiply numbers of possibilities of different parts of something to get the total number of possibilities, as seen in the outfit problem. When we are counting something where order matters and we replace what we are choosing, the formula is n, which is the number of things, to the power of r, which is the number of times we choose those things. When we are counting something where order matters and we do not replace the things we are choosing, we use the permutation function, npr equals n factorial over n minus r factorial. When we do not replace things and do not care about order, we use the choose function, n choose r equals n factorial over n minus r factorial times r factorial. So we have ways of choosing things with replacement where order matters, without replacement where order matters, and without replacement where order doesn't matter. This raises the question, what about when we're choosing r things from n things where we replace each time but do not care about order? This is an interesting challenge, and I encourage you to think about it. It is a little bit more challenging, though, so I will answer it in a future video. Thank you for watching.